So we're moving into a new unit, which is about systems of linear equations. Now, obviously, we're still talking about linear equations like we did in Unit 1, except now we've got to talk about what a system is. Now, the word system in everyday life is talking about several moving parts that work together to meet one goal, right? So that's exactly what's happening here. I have a system of equations. I have several linear equations that work together to meet my goal, which is find my solution. Now, a solution are the coordinates that go in x, y, and z that create true equations. So solutions create true equations. But because I have 3 variables, and in Algebra 1 you learned about 2 variable systems, but because I have 3 variables, that means I need 3 equations in order for me to solve this. It is not enough to have 1 equation because there's too many unknowns there. So we are going to break it down a little bit systematically. Haha, it's a system of equations. My recommendation to you starting out would be to number your equations. I'm going to number them 1, 2, and 3. Now this is not part of the solving process, but it is something that's going to help you keep your work organized. And I will tell you that in solving a system of equations, the more organized you are, the easier it is going to be for you to solve these. So the first thing that you're going to do, and this is through the method of substitution, our next lesson is going to be a different method. So we're going to focus on substitution here. And our first method is going to ask us to, obviously, substitute. So my first step is to solve one equation for a variable. Okay. Solve one equation for a variable. You can pick any one of these 3 equations and you can pick any one of these 3 variables. It's just going to be up to you based on what you think is the quote-unquote easiest one. So I can see in this first equation, z would be pretty straightforward to solve for. And in the second equation, x would be pretty straightforward to solve for. In the third equation, none of them are really straightforward. Again, you get the choice, okay? Although you and a friend might pick 2 different equations to solve for at the beginning, your work will look different, but ultimately you will come to the same solution. It's like taking 2 different roads to get to the same destination. So I'm going to actually pick x. I feel like it, so I'm going to pick x. So in order to solve for x, I need to add 2y to both sides, and I need to subtract 2z from both sides. So I end up with x equals 4 plus 2y minus 2z. Okay, now I did all of that in order to now use that to substitute. Okay, so I am going to, wow, go figure, substitute. So this is where us having numbered our equations is going to come in handy. So notice that equation 2 is the one where I isolated x. Since we're talking about substitution, I'm going to take this right here, which is what x is equivalent to, and I am going to substitute this into my other 2 equations. So I'm going to substitute it in for x right over here and substitute it in for x right over here. And it just helps you keep your work straight. So since I solved equation 2, I'm going to start back up with equation 1, which was 3. And now instead of x, I'm going to substitute in 4 plus 2y minus 2z. Plus 2y plus z equals 1. And now all I'm going to do is simplify. Again, I am not solving, I am just simplifying for now. So I'm going to distribute 12 plus 6y minus 6z, bring down plus 2y plus z equals 1. And then combine my like terms. So I have 12 plus 8y minus 5z equals 1. Now I've got 2 variables here and I've still got a constant. So I'm going to now subtract 12 from both sides, which leaves me with 8y minus 5z equals negative 11. Once you get to that point, I just zoomed in a scooch. Once you get to that point, you are going to want to pause. Okay, so right there, I am going to now pause. And I am going to now grab equation 3. Equation 3 was the other equation that I had not solved. And I am again going to substitute this expression in for x. So I have 2 times, my x is 4 plus 2y minus 2z. And I bring down everything else. Plus 4y plus 3z equals 9. And just like before, I want to continue to simplify. I'm going to distribute, so 8 plus 4y minus 4z, bring down plus 4y plus 3z equals 9. Combine my like terms, 8 plus 8y minus z equals 9, and subtract 8 from both sides. And again, now I am going to pause. So what I have done at this point is I have now substituted x into both of my other equations, and now I'm actually left with a 2-variable system of equations. I've got 8y minus 5z equals negative 11, and I've got 8y minus z equals 1. Once you get to this point, you are going to solve the 2-variable system with these. Now, if you don't remember how to do that from Algebra 1, there's tons of resources out there for you, and of course, I am going to solve it in this example as well. So we're going to say solve the 2-variable system just created. Okay, so now what I'm going to do, sorry about that, it got frozen. So solve the 2-variable system that you just created. So now what I'm going to do is I am going to take these two and I'm going to stack them on top of each other and solve my system of equations. And since we're doing substitution, I am also going to solve my 2-variable system by substitution. Although in the future you will be allowed to do whatever method you want, but let's practice going over them first. So let me go ahead and stack these two on top of each other. I'm going to say 8y minus 5z equals negative 11, and 8y minus z equals 1. And you'd basically do the same process again. I solve one equation for a variable, and then I substitute into the other equation. So if I'm looking between these two, it's pretty clear to me that the second equation is going to be pretty straightforward to isolate my z. So let me go ahead and give my step. Solve one equation for a variable and substitute into the other. So I am going to choose to solve the second equation for z. So let me go do that. 8y minus z equals 1. So I need to subtract 8y from both sides and divide everything by negative 1. So I have negative z equals 1 minus 8y. And then when I divide everything by negative 1, I'm left with z equals negative 1 plus 8y. Z equals negative 1 plus 8y. Now this was the second equation that I solved for z. So I'm going to take this right here and I'm going to substitute it in to this z. Very similar process, except now I'm down to 2 equations instead of 1. So let me just copy that back down. Like I said, the more organized you are, the easier this will be for you. And even if that means a little bit more writing than you are normally used to. I want to substitute it in right there. So I'm going to say 8y minus 5 times negative 1 plus 8y. Now, I love solving systems. My only issue with them is because there are so many moving parts, you do have to be very careful because it can be very easy to make a simple mistake and then it unfortunately ruins your whole problem. And since it's so long, sometimes it's hard to find where you made that mistake. So now I have 8y I have negative 5 times negative 1, which is plus 5, minus 40y equals negative 11. And just like before, I am now going to simplify, except the difference now is I'm left over with only y's. So I can actually solve this equation. How cool is that? Combine my like terms. So I'm left with 5 minus 32y equals negative 11. Subtract 5 from both sides. 32y equals negative 16. Divide everything by negative 32, and that actually leaves me with y equals 1/2. Okay, y equals 1/2. I finally got a value for one of my variables. So I'm going to take this y value, and I am now going to go back into either one of these two or into this equation here and solve for z. Since z is already isolated here, I'm actually going to use that one. So I'm going to say, hey, I remember that z is equal to negative 1 plus 8y, but now instead of y, I am going to substitute in this 1/2 value I just found. Pretty cool. So I have z equals negative 1 plus 8 times 1/2. And then I just finished simplifying really quickly. So I have z equals negative 1 plus 4, and so therefore z is equal to 3. Oh my goodness, I'm almost there. Remember, my goal is to get x, y, and z solved. So I've got y is equal to 1/2, I've got z is equal to 3. Now I'm just left over with x. So now I go all the way back to the top. I go to my original equations, and I take my y and I take my z, and I get to pick any of these equations and substitute in my y and my z to get x by itself. But hey, remember this second equation where I had already isolated x? Well, why don't I substitute y and z in here, and then I'll already have x isolated. So let's go do that. Recall that x equals 4 plus 2y minus 2z. So in place of y, right over here, I can substitute my 1/2. And in place of z, right over here, I can substitute my 3 that I just solved for. Let me move it up so we can see the 3 again. So let's go do that. X equals 4 plus 2 times 1/2 minus 2 times 3. And then I just have to go simplify that. That leaves me with x equals 4 plus 1 minus 6. 4 plus 1 is 5. 5 minus 6 is negative 1. So now your final answer is a coordinate, x comma y comma z, where x is negative 1, just solve for that. Y is 1/2, just solve for that. And z is 3, just solve for that. And that right there is the system solved using substitution. And you can verify that it is the solution by taking this x value, this y value, and this z value, and substituting them all in for each of these 3 equations. When you substitute in, if you get a 1 in the first equation, a 4 in the second equation, and a 9 in the third equation, if you get all of those, that tells you that, hey, you definitely did do it correctly. The last thing that we're going to do is practice writing a system from a word problem. We're not actually going to solve that one. We're just going to practice writing. And then I will give you the answer in case you want to go solve it on your own to see how comfortable you are by this point. A photo album has 80 pictures. Each picture is a square, a rectangle, or a circle. There are 12 times as many rectangles as circles. There are 10 more squares than circles. How many of each type of photo is in the album? So before you start writing any sort of equations, you have to go first decide, okay, what information is it that I do not know? Well, what I don't know is how many square-shaped pictures are there, how many rectangular-shaped pictures are there, and how many circular-shaped pictures are there. And those three things become my three variables. So let's go define our variables first. This is very important. You can't just go throw down random letters onto your paper, calling them variables and saying, oh, this is what I'm using, without telling your reader what information that means. You have to define your variables. And you simply do that by saying, okay, well, I'm going to say that S is the number of square photos. I'm going to say R is the number of rectangular photos. And C is the number of circular photos. Do not assume that your reader knows what S, R, and C stand for. You could, of course, even use X, Y, and Z. So now I go back to my reading and I say, okay, what information am I given? I'm told that there are 80 pictures. So that tells me that the number of square photos plus the number of rectangular photos plus the number of circular photos, together there's 80 of them. So that's my first equation written. The next piece of information is there are 12 times as many rectangles as circles. There are 12 times as many rectangles as circles. So I'm actually multiplying 12 times the number of circles to get the number of rectangles. So I can say that R is equal to 12 times the number of circles. 12 times the number of circles. Oh my goodness, that must be bothering you guys right there. Okay, there we go. All right, so there's my second equation written. 12 times as many rectangles as circles. And finally, there are 10 more squares than circles. It's telling me the information about the squares in relation to the circles. So it's saying squares is equal to 10 more than these circles. And those are my three equations. You can now use substitution to solve and tell me how many square photos there are, how many rectangular photos there are, and how many circular photos there are. I am going to write the answer down, but if you want to solve it on your own, pause this video, try to solve it, and then play. All right, if you did it correctly, then you would have gotten 15 square photos, 60 rectangular photos, and 5 circular photos. Or you could write that as a coordinate as 15, 60, 5, as long as you define, again, your variables for me, telling me which number represents which variable. If you need more examples, there are lots of extra resources out there. Tons of videos from lots of other teachers, and then of course you can always ask questions in class.